Okay. Dear colleague, dear faculty, thank you for your invitation. My presentation is oxygenator performance estimate from CO2 removal capacity during VV ECMO. There is no conflict. Everybody knows that during the procedure, the oxygenator plays a fundamental role to make the procedure successful, and general cases of failure of this procedure are usually due to the oxygenator during long-term use. Currently, with the new membrane of PMP, the previous problems are avoided, but ECMO can trigger a systemic inflammatory response, worsening the membrane lung performance due to thrombotic deposit on the gas exchange membrane. In this slide, we can see a schematic model of VV ECMO with the membrane lung and active lung in series related to metabolism of patient. We have the dead space, ventilated but not perfused, a shunt, perfused but not ventilated, and the percentage of blood with the idle VQ. But the three components must be evaluated in order to predict, the performance of the oxygenator and the natural lung condition. The function of oxygenation and CO2 elimination must be evaluated separately due to the fact that either of these two parameters could change independently from one another. The aim of our study was to evaluate the membrane lung dead space and the performance of oxygenator in terms of CO2 removal actually measured divided by the CO2 removal given by the factory. This is another indicator in addition to the standard PF ratio of the oxygenation. In fact, initially, all of the fibers are perfused and ventilated, but after a certain period of time, you can see the presence of a clot formation with the fibrin deposit in the membrane lung, which created the so-called dead space. In other words, the oxygenator has some fiber ventilated but not perfusion. The result is the progressive loss of performance in terms of CO2 removal. That means an increased partial pressure of CO2, the blood out of the oxygenator, and the reduction of the P-expired CO2 of a membrane lung sweep gas. During the VV ECMO, for a long period of time, a perfusionist evaluated the performance of membrane lung. How? We have many factors, many ways, but the principal factor investigated is oxygen transfer. Is commonly evaluated by membrane lung PF ratio, calculated between outlet partial pressure of oxygen and CO2 sweep gas. But the CO2 elimination, how can you measure it? Two methods, membrane lung dead space and VCO2 removal of the membrane lung in reference setting. In our study, we evaluated 7 membrane lung and used it in 4 different adult patients, means of age 50 years old. The method, most measurements were made at PCO2, post-oxygenator from the membrane lung blood outlet, P-expired CO2 and CO2 concentration at membrane lung sweep gas outlet with the infrared CO2 analyzer. And we calculated the dead space and the VCO2 membrane lung and the VCO2 membrane lung lesion. How? We evaluated the CO2 elimination by membrane lung with the CO2 capnometer. This method entails the insertion of a tube to the sweep gas outlet, which is connected to the side stream capnometer. And we obtained 2 measurements about gas outlet. Sweep gas CO2 partial pressure as mmHg and sweep gas CO2 percentage concentration. Putting the data obtained by the blood gas analysis from the capnometer, we obtained the dead space as shown in this formula. And we calculated the VCO2 membrane lung with another formula with SIP gas and CO2% concentration. But we have another parameter that CO2 theoretical elimination. In fact, this slide represents the factory data reporting the membrane lung CO2 bench reference value. We shouldn't forget that each company supplies the membrane lung CO2 value, and according to the EMI standard, during our practice, we have found that both manufacturers supplies the membrane lung CO2 are inferior to our result. In fact, the point represents measuring the ml CO2 on the first day in point green and the last day point red during the use of two different oxygenators. Membrane lung function deterioration should be reflected by the ratio between V ml CO2 and the corresponding bench reference value at the same gas flow, blood flow 1:1. The result, we consider the first and the last day of the use of every membrane lung. The duration of a membrane lung was mean 11.7, and the mean of the post-CO2 change from 36.8 mmHg on the first day to 44.7 on the last day of use, while mean P-expire carbon dioxide decreased from 28 to 24 mmHg. Using all data, we obtained this graph, where you can see the mean VCO2 ratio decreased to 0.97 to 0.5, and as we expected, the mean of the dead space increased from 24 to 47 on days. In according to PF ratio that decreased from 392 to 153 from the first and the last day. The conclusion: further investigation are needed to confirm the value of oxygenator assessment based on membrane lung dead space and the measured and theoretical VML carbon dioxide ratio. But the CO2 removal base index could represent additional early predictor of membrane oxygenator deterioration, thus helping choose the right time for oxygenator replacement before sudden loss of function. Thank you.